So hi, Ma, welcome to this video. This video is about cadcam for the mechanical engineers and unit 2. So unit 2 heading is also given here, geometric modeling. So we will be taking very important 10 questions into this unit 2 of geometric modeling, which is a cadcam software subject. So you will be getting here the explanation with respect to these diagrams and also theory more I will discuss. Less points I have posted here so that you can understand, you can spend your time more on this video and you learn, you note, you write the diagram in your exams and get pass. So let us today take the first question. That is first question of this video. The first question says this, explain about the representation of techniques in the CAD-CAM. So what is the representation techniques in the CAD-CAM? So geometric modeling techniques, if you are taking, generally it uses mathematics. It uses mathematics and also it is driven upon by is driven upon by driven data approaches to represent 3D objects in the CAD/CAM. So geometric modeling is a very important. So geometry itself says that it is using X, Y, Z and theta axis in order to form a figure. So to represent 3D in the CAD/CAM, which is a primarily classified into wiring edges. So first we will be forming this wireframe, so which is formed by using adjustment. Then surface is added to that wireframes. Then it will become a solid modeling, which is having a volume in it. The most common technique for 3D modeling are the constructive geometry. So constructive solid geometry, CSG. So this is the process. Wireframe surface is added, then it will become solid modeling. So this is one of the solid modeling is constructive solid geometry, which uses Boolean operations on the primitives, means given figures, and boundary representations. So boundary representations and which defines objects via the vertices, edges, and faces. So a object is created means it is created with the vertices, edges, and faces. So this I will discuss in the second video in the next question deeply. But here you can see what is a geometric model according to your syllabus, JN2 syllabus. According to your JN2 syllabus, geometric modeling is divided into two types, three types. B, boundary representation, constructive, solid geometries, and also VREP. Okay, this again, boundary representation is divided into discrete and functional based. Then again, this discrete is divided into polygon meshings. So meshing operations can be done means every element, every unit element is taken and it is tested here. So function based is parametrics. Parametric will take explicit functions, implicit functions are taken for this study. Now this VREP is again divided into here discrete and functional based. Here also you can see discrete means Excel, octree, polyhedral meshing. So these three are taken here and they are discreted and they are studied. Here functional based is parametric, explicit, implicit, same operations, but difference in this discrete systems we can see here, but no difference in the function based systems. This is the introduction of what is a representative techniques. So how you represent this geometric modeling from 2D to 3D. So this is, I think it is clear now. I'm going to take the next second question of your second unit geometric modeling. Explain about the parametric representation. So what is a parametric representation in geometry modeling? Defines curves and surfaces. So you are having some curves and surfaces which are using the independent parameters. Okay, and they are direct relationships also. So points are expressed as functional allowing for flexibilities. So points are used as flexibilities. Okay, Amb an ambiguous and precious representation of the complex shapes, free form of the curves, surfaces in the CAD/CAM software. So here you can see this is the circle is formed if you are taking a cone. If you're dividing a cone at the top side, you are getting a circle. If you come little bit down than the circle, then you will, if you are cutting a 45 degrees angle, then it is cutting an ellipse. So still down, if you are cutting, you can observe a parabola here. Still down, if you come, you can observe a hyperbola here. So these are the parametric representations. So circle, ellipse, parabola, hyperbola. So here you can see, unlike implicit forms, parametric equations, okay, makes it easier to calculate tangents, curvatures. So here you are having tangents. This is a tangent line you can see for the circle. Ellipse also it is having tangent line to bone shape as a parameter usually ranges within a finite interval of times. So what are the parametric representations in the cadcam means? We can say that they are divided into four types: circle, ellipse, parabola, and hyperbola. If you are taking circle, it is given by the formula x square plus y square is equal to a square. If you are taking the ellipse, if you can take x square by a square plus y square by b square is equal to 1. Parabola, if you are taking y square is equal to 4ax. Hyperbola, you can take x square by a square minus y square by b square is equal to 1. These are the standard formulas. No need to discuss more about this. So the third question, if you are taking, this is the explain about the non-parametric representations in the cadcam software or geometric modeling. So non-parametric refers to modeling techniques. You can make models, 3D models. Curves are statical models. So they should be curves which are statics, depend upon the maximum, and they do not rely on fixed predefined parameters. Okay, about the underlying data distribution. Instead of defining a shape, we set a formula. So a formula is set for everything, which is called as non-parametric formula. Okay, just you have to tell about formula. But whereas in the parametric, you have seen that it is made up of figures. Figures, it is made up of some figures. These models are drawn directly by the data points themselves, allowing for the high flexibility. Here in the non-parametric representation models, you have a high flexibility. You can change their dimensions by using mathematics, and adaptability as data size also grows. Here, flexibility. Models can fit complex, irregular shapes, patterns because the number of parameters grows with the data set grows. It is best example is nearest neighbors, decision trees, sprints are used. So if I'm taking this diagram, you can see this. What is parametric, difference between parametric and a non-parametric scale. Here you are having one here. This is a number of employees and number of salaries. Salaries they are taking on the x-axis, employees taken on the y-axis. Here some bar diagrams are drawn here. This is a generally parametric situation. Here this is a non-parametric situation. It is given by some lines. So average you will do the average and you will take the line here. So which is a non-parametric. So max is used because average is used means max is used, formula is used for the non-parametric. And here no formulas. Directly from figures you will get. Here you have to average or you have to take the mean or you have to do some operation, mean mode operation. So you are using formulas. That is it about non-parametric situation. Next, the fourth question I'm taking. Explain about the wireframe modeling. So what is the wireframe modeling? You can see that wireframe modeling. So wireframe modeling you can see as already as the before in question I have taken wireframe modeling. It is bounded by representatives. Boundaries are there. Here also boundaries are there. Inside all lines are there. Here also this is a spherical shape. Inside all this space, hollow space is there, but outside boundaries we can see. So wireframe is it is boundary bounded thing. Okay, wireframe modeling is the earliest, simplest, most fundamental 3D CAD technique. It is a very simplest form and fundamental form which represents the objects by their edges, lines, vertices, points, and curves. So here the concept is this one point, these 2 points are making one line. Some lines are making this plane, some planes are making this 3D object. So generally, basics is points make lines, lines make planes. Some planes here, 4 planes or 6 planes together form this wireframe model. Here, without defining surfaces or volumes, we are not concentrating on the surface or volumes. We are not going to be complicated. in wireframe model. It is easy to study. It acts as a digital skeleton. It is generally a skeleton or a fundamental. It is a wire structure. So if you use the wires, if you form a structure, it is like this. It is shown that enables quick, efficient, and low computing power. So easy to understand, efficient to understand, low computing power, visualization for preliminary designs, architecture layout, and CNC programming. It is generally used in this architecture layouts and CNC programming also. Okay, next, if I'm not wrong, I'm going to the next question, that is fifth question. Explain about the surface modeling. What is happening in the surface modeling? So, next fifth question, surface modeling. Explain about the surface modeling. What is happening in the surface modeling here? Surface modeling is a 3D. So this is the surface modeling. First, I will go to the diagram. See the surface modeling. So here it is surfaces are shown. A cone, circle. This is meshing. Freeform curved. This one, a plane which is having some curves. Here also a circle, 3D circle, a 3D cone, a 3D sphere. These are shown here. So what is happening here? Surface modeling is a 3D modeling technique that defines the boundaries, skins, or exterior shells. Only your concentration about the exterior part of the object, not internal part of the subject. Of an object without creating a solid volume. So we are not bothered about solid model inside. So that will be coming next, allowing for the precise design of complex shapes, curved shapes like car bodies, aeroplane wings. Okay, so for example, these are used in the car bodies, aeroplane wings. So inside everything is hollow. You are only borrowed about this outside structure designing. So once it is model, it is final, then you are going for the next process. So it uses mathematical representations, primarily parametric surfaces like Bezier, B-spline, NURBS to control surface curves. So in order to make these surfaces, you have to follow this, have a situation of Bezier curve, B-spline, NURBS, which will be discussed in the next question, offering better visualization and aiding in wireframe models. So this, if you satisfy Bezier, B-spline, NURBS, then only you say you are having a good surface modeling. Otherwise, you are not having a good surface modeling. So that is having, I will discuss. Components, unlike solid, so it is not like solid form. Surface models have zero thickness, no thickness here. We don't show thickness here. Without thickness, we are doing surface modeling. Though they can be used to calculate mass and volume in the engineering situation. So this is the fifth question explanation. Here I am already showed this one. So this is the only no inside volume. Only we are bothered about the external. Next question, sixth question I'm taking solid modeling. Explain about solid modeling in the geometry of the cadcam situation. Here, this you are seeing so many solid modelings. You can see solid models are there. For example, block, cylinder, cone, sphere, wedge. Okay, these all are solid modelings only. So solid modeling in the cadcam is a parametric situation. Okay, it is a watertight method for representing 3D objects by defining their complete volume, geometry, and topology. So here you can see volume. We are concentration about the volume. We are not facing about the external. We are concentrating about the internal volume surfaces. So here also, if you say this figure, A figure, totally they are having some volume. B figure, totally they are concentration on the volume. C figure, their internal geometry is shown, internal volume is shown. Okay, internal volume is shown. Okay, not bothered about external things. So here you can see only we are concentrating on the volume geometry. It is essential for the engineering, enabling accurate mass property calculations, simulations, and also simulation process we can do. So we can apply stress, temperature, strain models you can get by using finite element analysis method or CFD method here, and the generation of CNC codes for manufacturing. So, so CNC machines generally works on G codes, M codes here. Common techniques which include are constructive solid geometry and boundary representation. Okay, these two models are used in the solid modeling here. So this is the question. Next question, I'm going to take sixth question. So solid representation. What is a solid representation? So this is a solid representation. Dots are shown here. By dots, we are getting some lines showing planes. You can see this cube is formed in 3D figure. This is also a complex figure which is formed here. This is more complex figure, figure on figure. Okay, rectangular cube on rectangular cube. This is so solid representation in the cadcam creates complete unambiguous. Unambiguous means you are not confused. Don't get confused. It is giving complete information like that. The statement says 3D model contains both geometric dimensions and topologies data, enabling automated analysis and manufacturing. So this is giving you geometry means dimensions and also topology connectivity data, enabling automation analysis. So everything is made automated in the manufacturing. So primary methods include CSG using Boolean operations. Here you are going to use some Boolean operations on the primitives. Primitives means figures given to you, 3D figures. Boundary representation, defining shapes by their surfaces also. The CSG, if you are taking, builds complex models by combining basic 3D primitives. So you can combine 2-3 figures, for example, block on cylinder, cylinder on cone, on sphere, using Boolean operations. Like union operation means combination, union means intersection means subtraction. A difference means also subtraction. It is represented by any order of binarities. So here, in solid representation, you are going to base on union, intersection, and difference, which are called as Boolean operations in the software representation. See here, they are not subtracted here. Total figures are shown. If you subtract them by using the Boolean operations, you will get this solid representation. Okay, next question. Seventh question, introduction to boundary representation. Now, what is a boundary representation? As I am early told you, here early discussed in the questions. So this is a technique. Okay, boundary representation is widely used in the cadcam softwares. Solid modeling techniques. It defines a 3D object by its enclosing surfaces. So, a object which is closed, it should not be open. So, it is closed by its face, edges, and vertices, rather than its internal volume. So, only boundary we are gathered. We are not bothered about volume. It stores both topology data and also geometric data, making it essential for high precision manufacturing. So, you can also manufacture hollow things. So we are not bothered inside volume, but we are bothered on the representative figures. This representation, these lines we are taking. So for example, you can see this boundary representation definitely based on these vertices, edges, and faces. This is your face. This is also your face. Okay. This is face, you can say. This face, this face. Okay. Vertices. These are the vertices generally. And edges. This is one edge, this is one edge, 2 edge, 3 edge, 4 edge, and vertices, edges, and faces. So here, the BREP model consists of vertices means points. You have to take the points. Vertices means edges. You have to take the curves connecting to vertice faces. Surface bounded by this one. So vertices means points. 1, 2, 3, 4. Like some vertices made edges. Some edges are joined together, making these faces. So this is the meaning of this boundary representation in a short form to understand easily. So explain about this next constructive solid geometry representation. These two questions are very important in the unit 2, unit 1, unit 2 geometric modeling, because these are weighted questions and the matter content more in this explanation also. So this is CSG is also one of the cadcam representatives 3D modeling by combining basics parameterized shapes, primitives like cubes, cylinders, spheres. You can form cubes, cylinders, and spheres here using Boolean operations, union, difference, intersection. It defines complex parts through an procedure tree structure, allowing for easy parametric editing, high-level designs, accurate volumetric analysis in the manufacturing. So here you can see this is union. Union means combines two volumes into one volume. Difference removes one shape from the another shape. Intersection retains only the volume common of the two shapes, which is common of the two parts. It will be using. So this is the this one explanation. Here you can see here wire polyhedras shell polyhedras shell two circle in a circle rectangle in a rectangle. Here wire polymedra only whites are used here. Here lamina polyhedra. So this is a lamina thin polyhedras. Here we are having open three-dimensional open box, open cylinder. This is so here you can see we are representing some points, vertices, spaces here also. Can make some planes are there, some planes are making 3D figures here. These are 2D figures only. Points, lines, here also point lines, point lines. So some vertices make faces, faces make edges like that. This is discussed here. So with this, I am ending. I have covered 8 important questions in the unit 2. I hope you have understand. If any comments, suggestions from your side, please write in this section. Like the videos, subscribe the videos. I will be posting new videos which will be helpful for you, your subject. Thank you. Thank you for watching this videos.